So in this video we will see about merge sort. Merge sort is a divide and conquer approach. The general strategy of divide and conquer approach is divide the larger problem into a smaller one which is small enough to solve. So this part is called divide part. And once the problem is divided into a smaller problems, then all the smaller solution for the smaller problems, we need to find the solution for the smaller problems, and the solutions are combined to solve the large problem. This is conquer part. So this merge sort also follows the same divide and conquer approach. So the smaller problem which can be solved in a unit time for any sorting problem is array with only one element. So in a merge sort, the given input array should be divided into a smaller array until each subarray contains only one element. So this is a divide part. So once we divide that larger array into many smaller arrays, each contains only one element, then we need to conquer. So here conquer is by using two-way merging. So these smaller subarrays should be merged. Until all the smaller subarrays are merged, we need to repeat that two-way merging to solve the larger, to sort this larger array. So we will give one example for this. So initially, first in the divide part, we need to divide that larger array into a smaller subarrays until the subarray, smaller subarray, each subarrays contain only one element. So how to divide that array? So we need to find a mid position. So mid position is the index of the start element 0 and index of the last element. So in this case this is 5, so 0 plus 5 by 2. So this is 2.5, and we need to take the floor value 2. So that means the left subarray should contain element from index 0 to index 2, and right subarray contains the element element at index 3 to index 5. So that means, so left subarray contains these three elements 9, 3, 7, and right subarray contains these three elements 5, 6, 4. So the same process should be repeated. So again this subarray, it will be divided into two subarrays. So the left subarray contains only one element 9, and right subarray contains two elements 3 and 7. So again this, the left subarray contains only one element 5, and right subarray contains two elements 6 and 4. So now this subarray contains one element, so no need to divide, and this subarray contains two elements, so we need to divide this into two subarrays, and this only contains only one element, so no need to divide, and this subarray contains two elements, so divide it. So now we divide all the subarrays to each contains only one element. So we complete this divide part. So next we need to conquer. So in the conquer we use two-way merging. We select two arrays and then we merge these two arrays. So for this, this array contains one element, this array contains one element. So the merging also takes only one comparison. So after this, after merging this, it will become 3 and 9. So now these two are merged. So again we need to merge this subarray 7 with this array. So 3, 9, 7. So after merging, it will become 3, 7 and 9. So now it is also matched. So now we need to take the next subarray 5. So we need to do the same merging. So after merging, this will become 3, 5, 7, 9. So now next subarray is 6. So we need to merge these two subarrays. So after merging, it will become 3, 5, 6, 7, 9. Now this subarray is also merged. So finally we have only one subarray 4 and this subarray. So we need to merge these two after performing two-way merge. So final array will contains 3, 4, 5, 6, 7, 9. So which is a sorted list of this original list. So this is the original list, and now we find the sorted list of this original list. So this is actually the merge sorts. So in the last video I already discussed about that two-way merging. So we divide that array into a subarray. Each subarray contains only one element. Once that subarrays are formed, and we take two subarrays at a time, and we do that two-way merging to merge that subarrays. So this is the pseudocode for the merge sort. It takes two input, low and high. Low indicates the start index of the current array. High indicates the end index of the current array. So initially low is 0, high is n minus 1. So and then I check whether that low is less than high. So low less than high means the array contains more than one element. If the array contains only one element, then low is equal to high. So if the low is less than high, it means the array contains more than one element. So we need to divide that array further. First I calculate this mid value. Once the mid value is calculated, I call that merge sort recursively. The first merge call that merge sort for the left subarray. So the left subarray start from the index low to mid. So and then next I call the same merge sort recursively for the right subarray. So the right subarray start from the index mid plus 1 to high. So these two recursive functions will be called recursively. So until this condition, this if condition low less than high become false. So the condition will false if only the array contains one element. So we divide that subarray into a array that contains only one element. These two recursive functions call will end. Then once the recursive function call ends, it will call two-way merge. The recursive function, the subarrays with only one elements will be merged. So this is the pseudocode for merge sort. Now we can derive the time complexity of this pseudocode. Since this is a recursive function call, we can go for a recurrence relation. So for the recurrence relation, assume that this merge sort is called with the input size of n. We can take the overall time for this merge sort as t of n, and this if condition. So this if condition, this statement will be executed. We take one time unit, and this merge sort, this is a recursive function call. So it calls the same function. Now we assume that this divide process divide that array into two equal sized subarrays. Now the size of each subarray will be n by 2. So this time taken for this recursive function, time taken to complete this recursive function is t of n by 2. because we assume this merge sort overall time for this merge sort we assumed as t of n with the input size of n. So now the same function merge sort with input size n by 2 takes t of n by 2. So now this also same function merge sort with size input size n by 2, so this also t of n by 2. And we already know the two-way merge for merging two sorted array takes time of n time complexity n unit times. So this is from this we can write the recurrence relation t of n equal to 1 plus t of n by 2 plus t of n by 2 plus n. So it can be written as 2 into t of n by 2 plus n. So this is the recurrence relation for this algorithm or pseudocode. Now if you apply Master's theorem or substitution method, then the time complexity can be derived as O of n log n. So for both best case as well as worst case, the time complexity for merge sort is O of n log n, because in quick sort if the array is already sorted, it becomes worst case and the time complexity will become O of n squared. Here, since though the array is sorted, still we follow the same divide and conquer approach. For the addition, for the worst case also it gives O of n log n. So this O of n log n is for both worst and best cases. Thank you.